Hello, student. Welcome to another video of straight to the point. Okay. Today we are going to talk about the quotient rule of exponents. Okay. The rule goes as follows: when dividing monomials that have the same base, you just need to subtract the exponents. Again, so a to the n divided by a to the m is equal to a to the n minus m. Um, or it's also equivalent to 1 over a to the m minus n. Okay, it just depends on whether or not you are moving uh, the exponent m, okay, to the top, or you are moving the exponent n to the bottom, right? Um, and if there's no more value at the top, then you put 1 there to hold its place. So to keep this video short, I will keep moving forward. All right. So applying the formula, uh, the entire goal of where to move it depend on what will help you have a positive exponent at the end. So I see 4 to the 7 divided by 4 to the 5th power. So since subtracting 7 minus 5 will give me a positive number, then I will move that exponent to the top. So that will give me 4 to the power 7 minus 5. And 7 minus 5 is 2. So that's 4 square. And 4 square is 16. 4 times 4 is 16. So my final answer would be 16. Okay. So I just put another example so that you can see a situation where we are moving the exponent in the denominator. We have 2 cubed divided by 2 to the 7th power. So it makes sense to move 3 in the denominator because 7 minus 3 is positive. So since I have nothing left in the numerator, I will put 1 there to hold its place. So that's 2 to the 7 minus 3. Okay. That's equal to 1 over 2 to the 4th power. And 2 to the 4th power is 16. 2 times 2, 4 times 2, 8 times 2, that's 16. So it's 1 over 16. Now, let's move to this one. All right. X to the 9 power divided by x to the 8 power. Okay. Again, subtracting 8 from 9 will give me a positive exponent. So I'm going to uh, use this formula instead, moving everything up in the numerator. So that would equal to x to the 9, 9 minus 8. 9 minus 8 is 1. So x to the power 1 is just x. Okay. X to the power 1 is just x. Anything to the power 1 is just that thing itself. So again, quickly, here is another example. This time, if I compare 11 and 15, 15 is greater. All right. So I'm going to move the 11 in the denominator. And since there is nothing in the numerator, I'll put 1 to hold its place. So uh, y to the 15, okay, bringing 11 down, minus 11. The exponent that you move is the one that changes sign, right? The one that you move is the one that you subtract, whether you move it in the denominator or in the numerator, all right? So we move 11, that's why we are subtracting 11. So 15 minus 11, that's 4. So it's a 1 over y to the 4th power. Okay, example number 3. So now when you have numbers, then you can go ahead and simplify those numbers first. Okay, we know that 12 divided by 2 is 6, and 2 divided by 2 is 1. So we simplify by 2, so that's just 6 6. Now, for the y, we are going to move 3 in the denominator. So we are going to be subtracting 3 from 5. So the 6, we have that right here in the numerator. And bringing 3 down will be 5 minus 3. And 5 minus 3 is 2. So now that's 6 over y square. Okay. Remember, because we have 6 in the numerator, we don't need 1 anymore. So let's move to this one. Okay, let me check to see if I can simplify the numbers, right? 3 goes into 15 and to 6. 15 divided by 3 is 5. So I have 5 right here. And 6 divided by 3 is 2. Okay, so I took care of that. Now between x cubed and x to the 10, okay, I will do 10 minus 3. That will give me a positive exponent. So I'm done with the number. That's 5 over 2. Now this 3 goes in the numerator. So 10 minus 3, which is x to the 7 power. Okay. Now, example 4. Now, I'll check the number 3 and 2. It's already simplified in the simplest form. So I don't need to do anything with 3 and 2 anymore, right? So let's move forward. 3 and 2 is already done. Now, between x to the 7 and x cubed, so I would subtract 3 at the top. I will move this 3 at the top, so I will not have any more x in the denominator. So 7 minus 3, that's 4. Now I move to the y. Okay, when I compare the exponents, okay, for me to get a positive exponent, I have to move the 4 in the denominator. So I'm going to be subtracting 9 minus 4. And 9 minus 4, that will give me 5. Okay, and then I'm done. Now, number 5, example 5 is not actually an example, it's a non-example. So remember, a monomial is a one-term polynomial, and right here we have a binomial that we are dividing by a monomial, right? So this one we cannot simplify further than this. So we are done with this. So be careful. The quotient rule does not apply here because of this plus right here. If it was subtraction also, we couldn't do it right here, right? So with the goal of keeping this video short, we are going to stop here. And I hope this makes sense. You can comment, and I see you in class.